All right, we're going to finish up the Unit 3 packet notes today. And this lesson is on bearings and courses. So when ships or planes navigate, they need a simple way to explain the direction they're traveling. So it's not like you can turn on the street or whatever. They have to use angles to be able to navigate. So there's two different ways. One way is a bearing. And a bearing will be in the form of either north or south, and then an angle in the direction east or west. A bearing is always drawn from the nearest north or south line. Right, and then the other type is a heading, and a heading is sometimes called a course, and is always drawn from the north line in a clockwise direction. So every time I think of a heading or a course, I think of like a clock. So you start at 12 o'clock and you rotate around in clockwise direction. Okay, so this first one, the bearing is north 60 degrees east. So from the north, you're going to rotate 60 degrees toward the east. All right, so you start at north, rotate whatever the angle is toward the east. All right, and then the course ends up being from 12 o'clock or the north, you rotate 60 degrees in the clockwise direction. Okay, the second one is south 70 degrees toward the east. So if this angle is 20 degrees, that would mean this one is 70 degrees. So from the south, you're going to rotate 70 degrees toward the east. Okay? And then for the course or the heading, we start at 12 o'clock and we rotate 110 degrees in the clockwise direction. So that would make this angle from the north 110 degrees. Okay, the next one, we have south 35 degrees west. So we start from the south and we rotate 35 degrees toward the west. That'll be that angle right there. Okay, the course we're going to start at 12 o'clock or the north and rotate 215 degrees in the clockwise direction. So this was 35 degrees from the south toward the west. The other one is 215 degrees from 12 o'clock. Okay, and the last one, north 72 degrees, 18 minutes toward the west. All right, so we start from the north and we rotate that angle toward the west. Okay, the course or the heading starts from the north or 12 o'clock and we rotate 287.42 degrees in the clockwise direction. And then this other angle, we started at the north and we rotated toward the west. All right, so we have some tips. So in word problems, whenever you're asked for a heading or a bearing, always look for the word from, and that's where you draw your XY axis. So sometimes it's at the beginning, sometimes it's at the end, so we have to pay attention to that. And if a bearing from A to B was north 65 degrees east, if we wanted a bearing from B to A, it'd be the same angle, but the opposite direction. So south 65 degrees west, and take you back in the opposite direction. All right, so for number 19, a jeep leaves its present location and travels along a bearing of north 62 degrees west for 29 miles. How far north and west is it, or of its original position is it? Okay, so we started at the beginning of the problem, the direction the Jeep is traveling. So we'd go ahead and draw our XY axis. Okay, and this one, the Jeep is traveling northwest. So from the north, we're going to rotate 62 degrees toward the west. So it makes this angle here 62 degrees. Now this is a little different from the other problems we've done where we're using the XY axis. We would always kind of use the horizontal for our angle. On these, it's going to be easier for us to use the vertical. Okay, so no, goes against all the stuff I told you in the last packet, but it's going to be smarter for us to draw this right triangle to the y-axis. Okay, and so I'm going to, we know that the Jeep traveled 29 miles in that northwest direction. We want to know how far north and how far west the Jeep traveled. Okay, so if I want to know the north distance, using the angle we have and the hypotenuse, we would say that the cosine of 62 degrees is equal to the adjacent, which is n, over the hypotenuse. And then the variables up higher, we're going to multiply. Okay. So we could just jot that in the calculator. So this Jeep has traveled 13.61 miles to the north. All right, and then to the west. Now, once you have two sides of a right triangle, you technically can do the Pythagorean theorem, but I know you guys can do the Pythagorean theorem at the back of your hand. So we're just going to go ahead and practice the trigonometry a little bit more to find west. I want to find the opposite. So I'm going to do the sine of 62 degrees is equal to W over 29. So W should be 29 times the sine of 62 degrees. And that should be approximately 25.61 miles. Okay, and then just a quick reminder, on the ACT or the challenge exam, you can stop at this part right here because you won't have that calculator. I mean, the ACT you could, but the challenge exam, you won't have the calculator to get the decimal answer. Okay, let's look at 20. A ship leaves a port traveling 15 knots for 5 hours in a direction of 285 degrees from the port. How far north and west is the ship from the port? So there are several things you need to know on this one. One thing, you need to know what a knot is. And a knot is a speed. It is a nautical mile per hour. All right. And then we need to understand what this 285 is. So that is a course or a heading. All right. And then don't forget that courses or headings are like a clock. So what we'll do is we'll start at 12 o'clock and we're going to rotate 285 degrees in a clockwise direction. So that should be 90 degrees. That's 180. That's 270, so 285 degrees. It's a little bit more. Okay, so we know that this angle is 285 degrees. And so we have a choice. We can draw our triangle either to the X or Y axis. It's up to you. I'm just going to go ahead just to keep it consistent, go to the Y. Okay, so I want the angle inside of my triangle. It would be 360 minus 285, or 75 degrees. All right, the distance that the ship traveled should be what I put on my hypotenuse, just like we did with the Jeep. We have different information. This time we have how fast the ship was traveling and how long. So anytime you need a distance and you know the rate and the time, you just multiply those together. So the ship has traveled 75 miles in that direction. Okay, so this distance is north and this one is west. Okay, so we are going to do two problems again. So to find our north, we are going to do the cosine of 75 degrees is equal to n over 75. A lot of 75s in this problem. All right, so we get approximately 19.41 miles. And then west, we would do the sine of 75 degrees is west over 75 miles. So approximately 72.44 miles. All right. And then the very last example. So a couple is hiking with a compass and they leave their camp and travel due south for 1.5 miles. Then they travel due east for 5 miles. How far are they from camp and what heading must they travel to get back to camp? So trigonometry technically could save your life. So we're starting at camp and they leave camp and travel due south. So I'm just going to go ahead and go south. And then they travel east. Okay. So I know this is 1.5 miles. I know this is 5 miles. And then from where they are, they don't want to go back the same way. They want to make a shortcut straight to camp. So that is where I'm going to draw my axis. Okay, so what I'm looking for from this triangle is this theta. So again, what I have and what I want, I am going to use tangent. So tangent of theta is going to be the opposite over the adjacent, which means theta is the inverse tangent of 1.5 over 5. All right, and then you can get that from the calculator by doing second tangent and that fraction. And we get 16.7 degrees. Okay, so let's answer the question. One of the questions was, how far from camp are they? Now, we can just use the Pythagorean theorem to find that. I just went ahead and did the square root. So that's 5.22 miles. So going this way is going to save them some distance, obviously, because they've already walked 6.5 miles, but it's only 5.22 miles back. Now it asks for the heading. So don't forget the heading is from the north around like a clock. So obviously it's not 16.7 degrees. 16.7 degrees on the heading would take you in the wrong direction. So that's kind of how compasses work. They are from the north. So So all I know is that this angle inside the triangle is 16.7 degrees. So we need to do some stuff with it. So I'm looking at this from here to here is 90, and then 180, and then 270, and then 16.7 more. So it would be 270 plus 16.7 degrees. So the heading we're looking for that we would use on our compass is 286.7 degrees. And then this is how far they are from camp. So if you're hiking somewhere with a compass and there's no cell phone service and you have your graphing calculator with you, this is how you get back to camp. All right, I'm going to go ahead and do this Jay and Sam on the hill question because every year people have some questions about it. It's number 11. Now we are not going to do number 12. Now if you wanted to try and figure it out, you could, but we don't really have time to worry about it. All right, so on 11, Jay and Sam, who are both on one side of a hill, are staring at the top of that 180-foot tall hill. Jay, who is nearer the hill, sees the top at an angle of elevation of 72 degrees 58 minutes, while Sam, who is further from the hill, sees the top of the hill at an angle of elevation of 41 degrees 23 minutes. How far apart are Jay and Sam? So this is kind of a strange question, but we're going to say the hill is here, and it's 180 feet tall. Right, and then Jay and Sam are over this direction. Let me try that again. All right, so Jay is right here, and he's looking up at the hill, 72 degrees 58 minutes. Sam is over here. He's looking up, 41 degrees 23 minutes. Okay, so I'm going to say Jay's distance from the hill is X, and then Sam, sorry I did this kind of low, this whole thing is Y. All right, so for J, to find X, I'm going to do tangent of 72 degrees 58 minutes equals the opposite over the adjacent. Right, and then the variables down low, you're going to switch. Okay, and so in the calculator, you would get approximately 55.146. All right, and then for Sam, or for Y, figure how far Sam is away from the hill. It's still tangent, but it's a different angle. So Y, you're going to switch. So Y should be approximately 204.290 feet. And then the question is, how far apart are Jay and Sam? So to figure that out, we would need to do Y minus X. And Y minus X is going to be 149.144 feet apart. Okay, so your assignment today is to do that on page 12, the 13 through 16. And then if you have extra time, you can go ahead and start working on the review, but the review will be the assignment for tomorrow. And the test will be the next day.